Okay, so there's the boundaries. Here we go. So the first one we looked at was clean star, and clean star means 0 or more of the preceding pattern. Yeah, I got a microphone today. The dot means any single character, so it's like the question mark in a glob. And then we had the square brackets, which is basically the same as in a glob. It's a single character that is any one of those things in there. And we can also give it a range, and we combine those two if we want. Here we've got the negation, which in the glob, according to the standard, it's exclamation mark, but the POSIX standard also says that a lot of shells may support hat for negation. So regular expressions just use the caret or the hat to mean negation of the single character class. All right, then we got another meaning of the hat. If it's at the front of a pattern, then that means beginning of line or beginning of input. And then correspondingly, if we want to indicate the end of an input, we have the $ to mean end of input. Okay, then we have all of this funny escaped things. So the W's, lower W means a word character, which again is underscore or alphanumeric. Capital W means a non-word character, so basically any character that is not underscore or alphanumeric. Slash lower s means a white space character, so that's a synonym for the space POSIX class, which is space, tab, line feed, new line, vertical tab, that kind of stuff. Capital S means a non-white space character, so basically anything that's not a space character. Now we've got the funny ones about position. So these are the same or similar to the caret and the $ to mean start of line, end of line. So the first one was slash lowercase b. So that means word boundary. And what that means is basically the edge of a word, where a word is defined to be a contiguous sequence of word characters. And the opposite of lower b is upper b, and that means a space that is not a word boundary. So when I see space, I actually mean location. So we're talking about an empty string in between two characters, or the empty string at the end of line or start of line. So it's a position, not a character, just like with the hat and the $. All right, then we've got these other guys, backslash less than sign and backslash greater than sign. So less than means at the start of a word, and greater than means at the end of a word. All right, then we had a whole bunch of practice that we went through, and you can review those. But today we're going to be looking at extended regular expressions. So they're called extended regular expressions because they add some more meta characters to the basic regular expressions. So our basics again were square bracket, dot, caret, $, and clean star. So egrep, or extended regular expressions, break some compatibility with basics because, well, if we're adding meta characters, then we have to break compatibility because now things that were literals are now meta characters. Okay, you can actually use these brackets in a basic regular expression, but it's really weird. You have to put a backslash in front of them to make them a meta character. So normally we'd use a backslash to escape something, to say that's not a meta character, it's actually a literal. But you can try to use these round brackets, for example, in a basic regular expression. But if you leave them as just round bracket, then it means literal round bracket. But if you put a backslash in front of it, then it means it's a round bracket meta character. All right, if that's confusing, I agree, it is very confusing. So I don't try to use round brackets in a basic regular expression. If I want to use them as meta characters, I just say that I'm going to use an extended regular expression, and that's it. All right, so we'll see examples of those when we get to them, so don't worry about it if it's confusing. So we're going to add two meta characters right away, the plus sign and the question mark. So plus matches one or more occurrence of the previous pattern. So we have clean star, which means 0 or more, but sometimes we want 1 or more. We don't want to allow 0, and we can do that with a plus in an extended regular expression. So our example here is b plus. That matches a single b, 2 b's, 3 b's, 4 b's, etc., but it doesn't match no b's. So it will not match empty string or 0 b's. So here's an example from a lexer for C. We've got some literals. What is it? Hashmark include, and then there's a space here, and then a plus. So this is saying there has to be at least one space there, but there could be more. So that will match include stdio.h with one space in between them, with two spaces in between them, with three spaces in between them, etc. So any number of spaces, but at least one. Okay, so since we're differentiating between one or more and many or more, zero or more, sometimes we want to say 0 or 1. And without a new operator, we don't have a way to do that, because it's either there's 1 or a bunch of them, or 0 or a bunch of them, but no way to say 0 or 1. So we got a new meta character for that, the question mark. Question mark will match 0 or 1 occurrence of the previous pattern. So for example, b question mark will match the empty string, because that's 0 b's, and it'll also match a b, because that's 1 b. So question mark is for 0 or 1. So here's an example, Truman, T-R-U-E, question mark, M-A-N. Before we had tried putting a clean star in this position, which allowed any number of e's, including 0. So with a clean star, it would have matched this thing with a whole bunch of e's. But now with the question mark, we can match Truman with no e and Truman with 1 e, but it will not match Truman with 2 e's or more. So here's another example from a lexer. We have a hash mark and then a space and a question mark. So that's saying there can be 0 or 1 spaces there, but not more. And then literal include, and then again, space plus. So at least 1 space, but up to any number of spaces. Okay, so 2 more sets of meta characters. We have or. So this is a logical or. So it's the same as the pipe character, but in regular expressions, it means logical or. If you read the documentation, I believe it's called alternation, because you have 2 alternatives that it could take. I think that's a terrible name, but that's what they called it in the docs. So here's an example, woodhouse or woodcock. So there's some precedence rules for or, but basically when we have a string like this, it will take that whole string to mean the previous pattern, and the string that follows will also be the next pattern. So it'll either be woodhouse or woodcock. These are from your text. All right, so now we got an or, we're going to want to make sub-expressions, because we'll probably want to say this sub-expression or that sub-expression. So round brackets in an extended regular expression are more meta characters. They're for grouping. All right, so here's an example, same as the previous one. Here it's wood, but then we've grouped this sub-expression, and it's either house or cock. So that will match woodhouse or woodcock. Here is another one, the 2 spellings of gray. So this will either match G-R-A-Y or G-R-E-Y. Okay, and this one is more practical for your usages probably. We've got an @ sign, and then it's either samp or code. And then we've got, this is escaped, so that means that's a literal curly bracket. And then it says there is a character class, so something that is not either of the curly brackets 1 or more times, and then a literal close curly bracket. So that'll match @code foo and @samp bar, but it will not match @code empty because there's a plus, so there must be at least 1 character between the 2 curly brackets. It will match code x with an extra curly bracket, unfortunately. Maybe we didn't want it to match that, but it will. Because remember, this is for substrings, and as long as this substring matches, then the whole line will be accepted. But it won't match this one. So if it tries to match @code, it's fine until it gets to the first open curly bracket, and then it gets to the close, but then the plus was not satisfied because there had to be at least 1 thing in between them. So it can try to go to the next character, but then the plus is still not satisfied because now we have a closed curly bracket when our single character explicitly said it cannot be a closed curly bracket. So that one would be rejected. So you can use round brackets in basic regular expressions, but you have to escape them, which is kind of backwards, because normally we escape to make a meta character into a literal. In a basic regular expression, if you escape a round bracket, it changes the literal into the meta character, which is absolutely bizarre. So I prefer not to use round brackets in basic regular expressions and to just tell whatever tool I'm using that this is an extended regular expression. So we got some practice here. You can see the answers because of the slides. So here is our pattern. It looks like we've got a logical OR between them, so it's either the left pattern or the right pattern. And the left pattern is the Wilco CXKS that we started with back in the basic regular expressions. And the right pattern is the example from above, where it's either Woodhouse or Woodcock. So if we give it Woodcock, and the question is, does it match or does it accept? Then the answer is yes. So it's going to match on the right-hand side of the OR. And it's pretty clear it's going to be wood and then followed by cock. So Woodcock. All right, so Woodhouse, oh, I hope that wasn't too traumatic for you. All right, Woodhouse, same reason. It's going to match the right-hand side, wood followed by house. All right, now we got this one, Wilco C Woodcock. So this will actually match in two different ways. So we can start by trying to match the one on the left. It says Wilco and then either a C or an X. So we got Wilco and then a C. And then any number of K's and any number of S's. Well, right there, between the C and the W, there are 0 K's and 0 S's, and CleanStar is happy to take 0 things. So this part right there will be sufficient to match the Wilco C. But also, this part here will also match. That'll match the right-hand side, because it's Woodcock, and we know that one matches already. So that one will match in two different ways. All right, next we've got Wilco Wood. So we can try to match it on the left-hand side, and it'll match the Wilco, no problem, for the left-hand side, W-I-L-C-O. But then there has to be either a C or an X, but there's not. There's a W, so it does not match the left-hand side. Okay, it also doesn't match the right-hand side because, well, we found the substring wood, but the substring wood has to be followed by either the substring house or the substring cock. So that one is no match, it's a reject. Okay, next one is Wilco CX. So that's going to match the left-hand side, Wilco, and then after the O, there has to either be a C or an X. So that C right there will match that. And then we can have any number of K's and any number of S's, including 0 of them. So that means it will match, because right there between that C and the X, there are 0 K's and 0 S's. So this pattern is satisfied. All right, next one is Wilco Co-XK. Or sorry, no, it's not. It's Wood Co-XK. All right, so let's try to match the left-hand side. To match the left-hand side, we need to have the substring Wilco. And Wilco is not in there, so it cannot match the left-hand side. All right, on the right-hand side, it does have the substring wood right here, but that has to be followed by either house or cock, and it's not, because we have C-O-X-K, which is not C-O-C-K. So that's a reject. Okay, the next one, we've got Wilco CXKS. Well, we already know that Wilco CX matches the left-hand side, so this one will as well, because it contains that as a substring. So that one is accepted for the same reasons as this one. All right, what about Wood COXKS? Well, if we try to match the right-hand side, we have wood, but it's not followed by house or cock, so it's rejected by the right-hand side. And then to match the left-hand side, it would have to have Wilco in it, and it does not have Wilco in it, so that's a reject. All right. Next one, it says WILCO-CKS. So it starts with Wilco, or it has Wilco in it at least. So it's going to probably match the left-hand side. So we got WILCO, and then it's followed by a C, so the pattern is satisfied up to the closey square bracket. And then it says any number of k's. Well, there's one k, so the k is satisfied. And any number of s's, there's an s there. So the whole string will match, so that is accepted. Now with Wilco Wilco x, well, it starts Wilco and it's followed by an x, which is what was required. And then the pattern says 0 or more k's and 0 or more s's. So there are 0 k's and 0 s's right there after the x. So that one is accepted. All right, next guy, Wilco ck, with a whole bunch of x's on either side. So remember, our patterns are for matching substrings, not entire strings. So there is the substring Wilco, so it's potentially going to match the left-hand side. So if it says Wilco, it has to be followed by either a c or an x. It's followed by a c right there. So Wilco c. And then it can have 0 or more k's. Well, there's 1k. That satisfies 0 or more k's. And then 0 or more s's. Well, after the k, there are 0 s's. So clean star is happy with that. Clean star will take 0 things. So this whole string is accepted because it contains the substring WILCOCK, which matches the pattern here on the left-hand side. Does anyone have any questions about those examples? All right, so if you do, just type it in and I'll catch it. Oh man, this one's a lot of fun. So normally I'd have you work this out with your neighbor, but since you can't, I will go through it. So describe each language. So I could potentially, on an exam, ask you a question exactly like this. Describe each language. So describe the language accepted by the regular expression. And then determine if it accepts the same as the one before it. And then there's a note. These are very tricky, because I remember last semester I got one of them wrong, because they are very tricky. All right, so the first one is not too bad. We got an A and an A. So that means it will accept strings that contain 2 A's in a row. Right, and it's important that those A's must be in a row. Okay, so any string that has 2 A's in a row within it will be accepted by this regular expression. Okay, and then the next one says AAA question mark. So here we've got 3 A's, but the question mark applies to the last A. So for this one, it says there are 2 A's in a row, and then there's either 1 A or 0 A's. So if we're allowing for 0 A's, then really all this says is there has to be 2 A's in a row. So it's the same as the previous, because this guy says there has to be 2 A's in a row, and this one also says there has to be 2 A's in a row, because it says there has to be either 2 or 3 A's in a row. So anything that has 3 A's in a row will also have 2 A's in a row. So they're the same language. Okay, now the next one says A question mark A. All right, so this says there has to be an A, and then either 0 or 1 A's, and then an A. That's the same as what we just said for this one up here. So there could be 2 or 3 A's in a row. And if there are 3 A's in a row, then there's definitely 2 A's in a row. So all 3 of these are the same language. All right, the next guy says AAA star. So remember, star means 0 or more, and it applies to that A right there. So we have to have 2 A's in a row, and then that has to be immediately followed by 0 or more A's in a row. So that could be 2 A's in a row, or 3 A's in a row, or 4 A's in a row, or 5 A's in a row, etc. But the minimum is there has to be 2 A's in a row. It says 2 A's in a row or more. So that is the same as all the ones before it. All right, let's look at this one. 0 or more A's, and then an A. 0 or more A's, and then an A. 0 or more A's. So we could have 0 A's here, 1 A there, 0 A's there, 1 A there, and 0 A's there. That's still just 2 A's in a row. Right, because the only A's that absolutely have to be there are this one and this one. So those two A's have to be there. The other ones, they don't have to be there because the star will match 0. So we're still just two A's in a row. Okay, so the next guy is AA+. So there must be one A immediately followed by one or more A's. So 2 A's in a row, 3 A's in a row, 4 A's in a row. That's what we said for the previous two. So this one is the same as all the ones before it. It just says contains 2 A's in a row. Okay. This next guy is a little different. He's got a group. It says, okay, I wrote the regex to highlight java.comments. Wrote this. Where's the comment? Leave the last line for the rest. I gotta parse that question later, because that is some crazy regular expression. I'll look at that once we're done the lecture. Okay, so this guy here has got a group of 2 A's, and then that has to happen one or more times. So we could have 2 A's or 4 A's or 6 A's or 8 A's or 10 A's, etc. So we have to have these repeating groups of 2 A's. Right? But because this is a plus, it says this happens one or more times. So the minimum substring we could produce, or the minimum string that would match this, is still 2 A's in a row. Now you might wonder, will it still accept 3 A's in a row because it does have them grouped? I think the best way to find that out is we're going to take this and run it and see what it has to say about it. So I'm just going to echo. First I'll just echo AA. I'll pipe it into grep, and this is an extended regular expression, so you have to say -e to tell it that it's extended. And it's extended because it uses round brackets and the plus. All right, so there we go. That matched. Let's give it 4 A's, like that. So that matched as well. This time, let's give it just the 3 A's. Now here, you can see it highlighted the first 2 A's in red because that's the substring that matched. So again, remember, we only have to match a substring, not the entire thing. So here it says we got AA plus grouped, I should say. So grouped AA and then plus. So 2 A's in a row, there's 2 A's in a row. So even though this looks like it's going by evens, or an even number of A's, it will still accept 3 A's because 3 A's contains 2 A's. So 2 A's in a row. That is the same as all of the ones that came before it. All right, the next one says, we got an A, and then a grouping of A plus question mark A. All right, well, I don't even need to look at what's in here because the question mark says there could be 0 of them. Right, and this is still an A. If it was a B, it might change things, or if it was any other letter, it would change things, but it's not. It's still an A. So what does this say? Well, we could have an A followed by one or more A's, or not, and then an A. So this little grouping in here, it's the same as A star. So it says one or more or 0. That's A star. And we talked about that up here and up here. So the only real requirement is if this question mark matches 0 things, then we've got an A followed by an A. So 2 A's in a row, which is the same as all the previous ones. Okay, now we've got the same kind of thing, but expressed in the opposite way. We have the question mark inside the brackets, and then the plus on the outside. So let's just look at the brackets to see if it's contributing anything. So inside the brackets, it says 0 or 1 A's, and that has to be repeated 1 or more times with the plus sign. So 0 things at least once is still 0. So we could still have no A's in between. So really all this is saying, again, 2 A's in a row, because we have this A on the left, and then we could have nothing on the inside because of the question mark, and then an A on the right. So 2 A's in a row or more, but anything that has 2 or more also has 2. So all of these languages so far are the same. All right, next guy. We've got a group AA question mark, and then we've got a group AA plus, And then we've got a group AA star. So when I'm looking at these things, I always ask, does this thing on the left and does this thing on the right actually contribute anything to the pattern? In this case, it's no, because there could be 0 things on the left, because question mark will take 0 things. And there could be 0 things on the right, because star will take 0 things. So really, it just reduces down to this thing in the middle. So we got AA grouped together and plus, which is exactly the same as this one here. So this one is also the same as all of the previous languages. And all it says is there must be at least 2 A's in a row. Because again, this can match 0 things, the clean star can match 0 things, and the question mark can also match 0 things. So if this contributes 0 things and if this contributes 0 things, the only thing that matters is the thing on the inside here, which is AA grouped plus, which we talked about up here. Even if we give it 3 A's, that will still contain 2 A's, so that'll satisfy the plus. So it's really just must contain 2 A's in a row. So it's the same as all the ones before it. All right, the next one, I'm going to look at it the same way. Do the things on the outside actually contribute anything to this pattern? Well, this says dot star. So dot star is 0 or more of any character. Well, if there can be 0 of them, then it doesn't contribute anything. Likewise here, dot star, there could be 0 of these things on the left and 0 of them on the right. So they're not really contributing anything to the pattern. So we're just left with AA, which is exactly what we started with. So all of these are exactly the same. Well, they're not exactly the same. They match in different ways, but they describe the same language. It's just 2 A's in a row. It must contain 2 A's in a row. So if I asked you to describe the language matched by the regular or accepted by the regular expression, if I give you any of these, I would want to see 2 A's in a row, or contains 2 A's in a row. That would be the perfect answer. If you give me literally like 2 A's in a row once or twice, and then 2 A's at least once, and then 2 A's 0 or more times, I would not accept that, because all you're doing there is just reading me literally what it says. I would want it in plain English. So you'd have to work through it a little bit. You probably wouldn't get this one on an exam, but something like this one would be fair. And for that one, I would want to see contains 2 or 3 A's in a row. But if you just wrote down contains 2 A's in a row, that's exactly what I would want. Because if it has 3, then it must have 2. So no, I wouldn't want each step of the meta characters described. I would want it summarized in plain English. So all of these guys just say contains 2 A's in a row. And you have to say the in a row, because if it contains 2 A's, that's a different thing. Actually, that's what these ones are. All right, so let's do the next ones. We got A star. So that's an interesting one, because a lot of you will get this wrong on an exam. I will give you A star, and then I'll give you the string B and ask you, does the pattern accept the input string? So does A star accept B? So think about that for a moment. If the input string was B and the pattern was A star, does A star accept B? Okay, oh, I didn't want a terminal. I wanted a file. And why is my bash not so? Oh, there it goes. So let's take a look. If our pattern is A star and our input string is B, the question is B accepted by A star, or does A star accept B? And the answer is yes, it does. Okay, so what does A star mean? It means 0 or more A, and again, that's in a row, like that. All right, well, 0 or more A's in a row. So the question is, does this string contain 0 or more A's in a row? Yeah, it totally does. Right there before the B, there are 0 A's, so it's accepted. Right here after the B, there are 0 A's, so that's 2 different ways that it's accepted. So really, if you see a star or anything, any single character star, you can have 0 of those things. And so if this says 0 or more of something in a row, well, if you have 0 of them, then that matches the empty string. Okay, and every string, oops, sorry, that should be an F. Every string contains the empty string. Right, so this B, there's an empty string in front of the B, and there's an empty string after the B. So you have to watch out for something like that. This does not require any A's, because clean star will happily take 0 A's. So if you break this down, it accepts everything. So if I gave you this one on the exam, I would want to see accepts everything. All right, well, let's look at the next one. So we've got a single character that is not an A, star. So I could ask you, are these two the same? So the way the question would be on an exam would be, are they the same? If they are the same, you have to describe the language that they match. But if they're not the same, you have to give me a counterexample that matches one of them, but not the other one. And then you'd have to also say which one it matches. So let's do that together. So we got A star here. I just made the argument that that matches everything. Okay, and then the next one is not A star. Well, there could be 0 of these not A's. So this will match the empty string. And every string contains the empty string, so it also matches everything. So they both accept everything, both of those. So that means they're the same language, even though they look like they're opposite. Because they will both accept the empty string, they are the same language, because every string contains the empty string. All right, let's look at the next one. It says not a question mark. So we could have 0 or 1 characters that are not an A. Well, if we can have 0 of them, then it will match the empty string. And again, every string contains the empty string, so it will match everything. So all 3 of these are the same. All right, the next one is a single character that is not an A. So this one actually requires a character to be there. The thing about these 3 before it, they don't require any characters. There can be 0 characters. But this one, there has to be a character. Okay, so that alone tells you that they're not the same. Because these will accept the empty string, this one will not. So that's the counterexample. You could give it the empty string and you'd say, the empty string matches all 3 of these, but it does not match this one, because this one requires a string to be there. Or sorry, requires at least one character that's not an A. So that is how they're different. Now the next one, it says a single character that's not an A 1 or more times. Okay, so if we compare it to the one right before it, this was 1 character that is not an A, and this is 1 or more characters that are not an A. Well, if we have 1 or more of something, then you have 1. So these 2 are the same language, and it just says contains a character that is not an A. Right, and because this is the same as that one, we also know that this one is not the same as those 3, because this one wasn't. All right, next one. Oh, this is a fun one. A \BA. So remember, \B means a word boundary. So think about what that one is saying. And remember that /B matches a location, not a character. Ugh, I keep hitting the microphone. Sorry, guys. So it says there's an A and at a word boundary, and then another A. So let's take a look at that. A \B A. So it's saying there's A, and in between them there's a word boundary. That's not possible. If we have 2 word characters in a row, the space between them is not a word boundary, or the location between them is not a word boundary. So this is impossible. you can never have two A's in a row with a word boundary between them. So this regular expression, oops, sorry, where'd he go? There he is. This regular expression rejects everything. It's not possible to create a string that will match this regular expression. So this guy rejects everything. All right, so if that rejects everything and the one above it contains an A, well, then they're not the same. Because if I give any string that contains an A to this one, it will be accepted, whereas this regular expression down here rejects everything, so nothing will be accepted. So a counterexample, if I was to give a letter B or the empty string, oh wait, no, this guy doesn't accept the empty string. Okay, A hyphen A, sure. So A hyphen A, well, the hyphen is not an A. So that will be accepted by this language on the top, right? Because it contains a character that is not an A. The hyphen is not an A. So that's accepted by this one. It's actually going to be rejected by this one. So we'll take a look at it. If you're looking at the string A hyphen A, okay, so the language here is saying there's an A. All right, we're fine up to here, so I'll just put a pipe there to say we're fine. That matches that, and then there's a hyphen. So there's a word boundary between the A and the hyphen. So we're okay up to this point of the regular expression, but then it says there must be an A. So remember, the B's are talking about a position or a location, not a character. So the B matches the position between the A and the hyphen. But then my regular expression says that must be followed by an A. But it's not, because it's followed by a hyphen. So that's rejected. Right, so the B's do not consume a character. They are talking about the position right here, not the character right there. Now, if we had said, if we had said that, then this would be accepted, because we've got an A, and then a non-word character, and then an A. So that would be accepted. Okay, that's a good question, and that's a common mistake, so I'm glad you asked it. All right, let's look at the next one. We got an A, and then a non-word boundary, and a hyphen. So this one is also impossible, because this is describing a location, not a character. And if we have an A followed by a hyphen, then that space between them, or that location between them, that is a word boundary, because we transitioned from a word character to a non-word character. So that has to be a word boundary. So it's impossible to have a non-word boundary between an A and a hyphen. So this one also rejects everything. There is no input string that will be accepted by that regular expression. So that means these two are the same language, and that language is rejects everything. Okay. Let's look at these guys. Sorry, one of the ferrets just got up. All right, what do we got? We got an A dot star A. So there's an A, and then there can be any number of anything, including 0 things, and then an A. So this one says contains 2 A's. They don't have to be in a row. They can have anything between them, just that there are 2 A's. So contains 2 A's. Now, the next guy says an A, and then 0 or more not A's, and then an A. So I'm going to copy, or actually I'll just type it out because it's hard to copy from the slides. So let's get rid of all of these. So we were looking at A dot star A, and I said that means contains 2 A's. Okay, they don't have to be in a row, just anywhere. Now the next pattern we had was A, and then not A, star, and then A. So we got to think about what is this one saying, and is it different from the other one? All right, so that's the only potential difference really is that the thing in between the A's here must be a not A character, whereas up here it does allow for other A's. So this one up here will match 2 A's in a row, or 3 A's in a row, or 4 A's in a row, or 5 A's in a row, whatever. but it will also match an A, a B, a C, a D, and then another A. So as long as there are two A's, they can have anything in between them. But this one here says there's an A, and then 0 or more things that are not an A, and then an A. So again, it contains two A's, but there cannot be an A between those two A's. So it seems like they're different, but they're actually the same. And here's how. If I give the string AAA, right, then this one right here will accept it, and it will say the dot takes that middle A. So let's actually run this guy. So we'll do, and actually I'm going to use some bashisms since we're in bash. We're looking for grep to a dot star A, like that. And actually I'll just run it interactive. If I give it AAA, then you can see it says it matched, and it matched everything. And if I hold down the A like that, it also matches everything. Right, because what it did was, remember, star is greedy, it eats as much as it can. So this A right there matched the first A. Okay, and then dot star is greedy, so it's going to take as much as it possibly can. And remember, this is a non-deterministic finite automaton. So it always makes the right choice about how much to take. So it's going to eat all of these A's, and then it will leave the one left right there to be matched by that A. So the dot star actually matched all of that on the inside. Okay, so all that needs is two A's with anything in between them. Like I'll just type some garbage and even some funky characters. And then as long as there's an A, it will match that. Right, here was the first A, then the dot star part, and then there's the last A. All right, but now our new candidate pattern is this guy. Now he looks different because it says there has to be not A there. Hold on, somebody's going to come visit. This is Scotch. Yeah, she likes to help. Oh, thank you, Scotch. Okay, good girl. Go play. Hey, no, you can't come on the keyboard. Oh, there she goes. All right, so we're looking at this pattern here, which says an A, and then 0 or more not A's, and then an A. I make the claim that these are actually the same. And this will be how they're the same. If I give it two A's in a row, it accepts that, because we've got A, and then that's enough, because we have the first A matches the first A, and then the clean star in here will happily take 0 things, so it's satisfied. And then this A there is matched by that A there. All right? Okay, so what happens if I give this one 3 A's? It's accepted because it contained these 2 A's, and we already know those 2 A's are accepted. So let's trace it. We've got this A there, that matches that one. And then the space between those A's, okay, well, we'll say that's the clean star, so it takes 0 things. And then this one here, the last A, well, it's going to match that one right there. So there is a substring that matches the expression, so the entire line is accepted. So although it looked like those were different because the first one said there can be any character between the A's, and then the second one said there has to be non-A's between them, but because we allowed 0 of those things, then they're the same. Right, because we could have 0 not A's, or we could have 0 A's between them, so they're the same language. It's kind of the same argument we made about why these two are the same. Because of the stars, they could match nothing. So really, those two patterns only differed by what was here. But because the star, there could be 0 of those things. Yeah. Do you like my headphones? She really likes plastic and rubbery things, so she'll probably try to steal my headphones while I'm wearing them. All right, so let's look at the next one. We've got not A star, A, not A star, A, not A star. Okay. Okay, well, again, first thing I do when I look at these is I determine, do these things on the outside actually contribute anything? Well, this guy's got a star in front of, or right there. So that means there could be 0 of these things. So that doesn't contribute anything to the pattern. Same with the one on the right. There could be 0 of them. So that contributes to the pattern. Yeah, she's licking my neck now. She's very friendly. All right, so if the thing on the left contributes 0 and the thing on the right contributes 0, well, then we're left with A, not A star A, which is exactly the same as the one that came before it. So, no, that's mine. So this one is the same as that one, which is the same as that one. So all it says is contains 2 A's. Because again, this thing on the outside could potentially contribute nothing, because there could be 0 of them. Same with this one on the outside. Could potentially contribute nothing. There could be 0 of them, because it's clean star. Hey, you can't walk on my keyboard. Oh, you're so happy, I know. Okay, go play. Okay. Now the next one says, okay, we finally have got something that might break this. We've got starts with and ends with. And in between, we've got our friend A, not A star A, but it's bracketed also by dot star and dot star. Okay, so there's a potential that these are different because we're actually restricting what can be on the left and the right. So the reason that these two were the same is because any amount of A's could sneak in on the right or the left. But as soon as we have this thing bracketing it, we're saying this is end of line, start of line. So it could be possible that other A's could not sneak into this. Right, but we're saying dot star, so there could be literally anything on the left and literally anything on the right. So really, this thing here is not contributing anything. So that whole left from the star left, and here from the dot, the star, and the dollar sign isn't contributing anything because there could literally be anything there. That's what this says. Dot star means anything. So we've got anything A, not A star, A, anything. That's exactly the same as this expression right there, the second one in this column. Because there's no starts with or ends with here, so there can be anything on the left and the right. Right? And this one literally says there can be anything on the left and the right. So this one is definitely the same as that one. And since that one is the same as the other two, well then all of these are the same. Contains 2 A's. All right, next one starts with not A, any number of them, and then an A, and then dot star, and then an A, and then not A, any number of them, and then end of line. Okay, so here it looks like we're restricting what can be on the left and the right. This one says anything could be on the left and the right, but this one says those things on the left and the right, they can't be an A. All right, so maybe we're now in a case where we would actually reject 3 A's, but we're not, because the thing in the middle says it can take anything. So more A's can sneak in the middle, because the dot will accept other A's. So this is still just 2 or more A's. It does say no A's on the left, but it could be that the string starts with that A right there. Right, and if that's the case, we'll say, well, there's 0 not A's on the left, which is accepted by the clean star. Same argument goes for the right. So there has to be an A, and then there can be anything, and then there has to be an A. And on either side of those 2 furthest A's, there can be any number of not A's. But if these are the 2 furthest A's, then there could be any number of A's in between them. So still, we just have contains 2 A's. So that one is a little more complicated. So if I was to write a proof, I'm never going to ask you guys to write a proof. I would say just take these 2 A's to match the furthest extremes, and then you do a proof by contradiction to show that if there is something that doesn't match, then there must be an A on the left of it or an A on the right of it. But that's a contradiction because we said this A here, that is the one furthest left, and this A there, that is the one furthest right. So there cannot be an A to the right or the left. So therefore, all it says is matches 2 A's, which means it's the same as all of the ones that came before it. All right, next guy starts with anything, and then an A, anything, an A, anything, ends with. I don't know why that one says harder, because that one's actually easier than the ones that came before it. All right, so we can have anything on the left, including nothing, and then an A, and then anything in the middle, including nothing, and then an A, and anything on the right, including nothing. So that still just contains two A's. So this one is the same as all the ones that came before it. I don't know why that one's matched harder. I think that one's easier, because it's actually the same as the very first one. The very first one says A, and then anything, and then A, but we didn't say starts with or ends with, so there could be anything on the right and anything on the left. So it is pretty much exactly the same as this one. Sorry, this one. Okay, next one. Starts with not A star, A, not A star, A, not A star, ends with. Is it the same as long as it contains a previous expression? No, because this one here, A, not A star, A, that is the same sub-expression as this one, A, not A star, A, but these two are actually different. And the difference is this guy here allowed anything on the left, including more A's, and it allowed anything on the right, including more A's. So this says contains two or more A's, but this one actually says contains exactly two A's. So 3 A's would be rejected, because, well, one of the A's would match with this one here, and one of the A's would match with that one there, but then the other 3 places that could possibly take the third A all say that they are not A. So you got any number of characters that's not an A, and then an A, any number of characters that's not an A, and then an A, any number of characters that's not an A. It starts with and ends with. So we cannot sneak extra A's into this string. So this language here contains exactly 2 A's. Whereas this one up here is just contains 2 A's. So this will happily accept 3, 4, 5, or 6 A's, but this one down here will not. So the counterexample would be the string of 3 A's. All of these guys up here will accept the string of 3 A's, but this one down here will reject the string of 3 A's. All right. So next up, oh my goodness. Okay, we've got a grouping of the thing that came before, but it's clean starred. So the question is it the same as the one that came before it? Well, let's look at it. We've got to find a counterexample. So I've got a notes out here, B. So in case this is a big hint, this is going to be your counterexample. This first regular expression will not accept that string because it has to have 2 A's, A, A. Okay, but this one here will accept it because we've got the same grouping as the one above. So it looks like contains exactly 2 A's, but then there's a clean star on the outside of it. So that means there could be 0 things. Oh, that's not your counterexample, because it says starts with, ends with. That's misleading. They are different, though. Okay, that's an error in the slides. Let's look at it. This guy says there must be 2 A's. All right, and this thing out here is clean starred, which means everything in the brackets could occur 0 times. So these two are different. This one down here will actually accept the empty string, but just the empty string, because it has to start with and end with the empty string. Right, because I could say, well, here's my funny grouping that appears 0 times because of the clean star, and then starts with, ends with. So I could give this one the empty string. This one will not accept the empty string because there has to be 2 A's. I could also give this one 2 A's, and it would accept it, so would this one. But I could give this one 4 A's as well, because the star would repeat twice. So the first 2 A's would match what's inside the brackets, and then the second 2 A's would match what's inside the brackets. And then we'd be done. This guy up here would reject 4 A's because it says exactly 2 A's. Whereas this one down here says exactly 2 A's repeated 0 or more times. So this one is actually saying contains an even number of A's. So it will reject an odd number of A's. So let's take a look at it. Okay, insert, there we go. I'll try to give it a single A, it's rejected. If I give it 2 A's, it's accepted. Oh, it's rejected. Why is it rejected? Because I didn't say it's an extended regular expression. Let me fix that. grep space -e space. All right, AA. There we go, that guy's accepted. If I give it 3 A's, rejected. But if I give it 4 A's, it's accepted. So this one is saying there's exactly 2 A's repeated 0 or more times. So it says contains an even number of A's, because we also allow any non-A characters in between them. So this one is contains an even number of A's. I don't know what that B's about. That's misleading. Some student probably convinced me it was right, and then I didn't check. Okay, next one. Well, we've got something that looks very similar. We've got this one here, which is the same as the one above it, but then it says followed by 0 or more not A's. Okay, so the question is, are they the same or different? I know from looking at it that it's the same, because no matter how many times this pattern over here on the left repeats, the one that is applied the clean star, we already have that it ends with 0 or more not A's. So saying that it ends with 0 or more not A's again doesn't contribute anything. So let me just show you that. So if I expand the clean star, at first it will accept nothing because it's a clean star. So let me just put it in. Like, whatever, home, delete, and there we go. So the first thing it'll accept is the empty string. And actually, it's got these guys. I might as well make it complete. So it'll accept the empty string, fine. If there are 2 A's, it'll match it like that. Right, so the first A will be matched by this guy, the second A will be matched by that guy. Okay. What if there are 4 A's? Well, if there were 4 A's, then it would match it like this. The first A is matched there, the second A is matched there, the third A is matched there, and the fourth A is matched there. Okay, I'll come back to that question. What if there were 6 A's? Well, it would match it like this. All right, so 1, 2, 3, 4, 5, 6 A's. All right, but notice every time I've done this, actually, I didn't do it right. This should have a star on it. Every time I've done this, it always ends with not a star. Okay, so let's just fill that in. So if I was to then tack a not a star on the end of it, it just says not a star at the end, not a star. So either of these clean stars could take 0 things. So we can have 0 or more not A's followed by 0 or more not A's. Well, any number of not A's is going to be followed by 0 not A's. So this is the same. So this expression right here is identical to that expression there, because any not A's that were taken by this clean star can just be taken by this one instead. In fact, because it's greedy, this one is actually going to take all of them, and then this one will get nothing, but it's happy getting nothing. So if I have this expression and I just throw on the end of it, and then there could also be a whole bunch of not A's, well, I've already said right here it can end with a whole bunch of not A's, or 0 of them. So adding it on to the end again doesn't change anything. So those two languages are the same. Where were they? So if this one contains an even number of a's, including 0 of them, this one also contains an even number of a's. The other way to look at it is, if you know that this one says contains an even number of a's, then throwing a bunch of not a's on the end of it doesn't change that. It still contains an even number of a's. All right, now let's look at this pattern here. Oh wait, you asked, would it accept AAB? All right, AAB. So we'll trace both of them. If I can copy it. Let's go back to the document. All right, so this starts with that, and this guy needs the ends with. All right, so let's look at AAB. AAB. Okay, well, let's just do the first one first. We say it starts with 0 or more not a's. No problem. There are 0 not a's right there before the a. So that part is satisfied. Then there's an a. Yep, there's an a right there. So I'm just going to put spaces to say where they match. So that matches there. And then there's 0 or more not a's. Yeah, no sweat. There are 0 not a's in between those two a's. So it matches to there. And then there are 0 or more not a's. Sure, the b is not an a. So that accepts. It is accepted. Now the one below it, so I'm going to put in again our string. Actually, I'll put it below like this. We've got AAB. All right, starts with, yeah, here I am at the start. And then it says there are 0 or more not a's. Yeah, there are 0 not a's right in front of that a, so no problem. So that's accepted up to there. And then the a matches the a, so that's accepted. And then there are 0 more not a's. Yeah, there are 0 not a's in between those two a's, so that's accepted. And then it says not a star. Sure, the b is not an a. Okay. And then we'll come out of our bracket, and then it says there are 0 or more not a's. So remember, our b here was actually taken by this sub-expression there. So it's really saying there are 0 or more not a's following the b. Yeah, after the b, there are 0 characters that are not an a. So that clean star is also accepted. So the whole thing is accepted. So both of them accept that. Okay, now the next one, what have we got? Something very similar, except we've changed the grouping. So changing the grouping could potentially change the pattern. Okay, so it says starts with all that junk and then ends with. All right, I'm going to go back to this one to compare it to, the very first one. So I'm just going to grab that, and I'll put it right below. Oh, I didn't grab it for some reason. No problem, we can fix it. That goes there, and that goes there. All right. So this guy says this thing here repeats 0 or more times. So if it repeats 0 times, then we must have the empty string. So the question is, will this one accept the empty string? Well, there's a clean star, so the thing that before it could happen 0 times, and there's another clean star, so this could happen 0 times. So if they both happen 0 times, it will accept the empty string. So they both accept the empty string. Yeah. Okay. All right, well, what if this thing right here repeated once? So it would look like that. Okay, well, let's compare it. What if this thing right here repeated once? Okay, and then it's followed by 0 more not a's, like that, and those are exactly the same. So if it repeats once, it's the same, so it can contain 2 a's. All right, what if this crazy thing repeats twice? Okay, there it is once, there it is twice. Okay, and then we'll compare it to this one. Probably should have kept the brackets on it so it's a little more clear. Whoops. There we go. So if this thing happens twice, we get that, and I'll just take the bracket off. Oh, I can't take the bracket off because, well, if I get rid of the star, then it's gone too, because the star applied to the bracket, and we already know it's repeating twice. All right, well, what do I get? I've got this pattern that is exactly the same. Actually, that's not right. I was just looking at that and thinking to myself, that cannot be right, because they're not exactly the same. Which one am I comparing to? This one. I grabbed the wrong thing when I copied. No problem. Okay, so what if that repeats twice? So we got that, and then it's followed by this outside the clean. That. All right, they look different. Okay, but they differ right here in the middle. So these spaces are not in the pattern. I'm just spacing it out to see that they match. So everything from here to the left is the same. And so if I remove them from the top, I get that. And everything from here to the right is the same. So I end up with this. Okay, now the question is, are these two things the same? And clearly they are. This says 0 or more not A's, followed by 0 or more not A's. And this one says 0 or more not A's. So, but remember, this sub-expression matches everything. And this sub-expression matches everything. So if we can have everything followed by everything, including the empty string, then that's the same as everything, including the empty string. Another way to look at it is if we look at this one here, right? We could think, well, whenever this repeats, it's going to put not A star right beside not A star, because this is the beginning and that's the end. So if we duplicate this, it'll have those two side by side every time. Well, not A star, like I said, that's everything and everything. So you only need to say everything once. So what we've really done here is factored this thing outside of the clean star right there. And I can do that because they'll be put side by side every time in the middle. So this one is the same. It still contains an even number of A's. And if you're not convinced, you can try shoving 3 A's into this one. It won't accept it. But if you give it 2 or 4 or 6, it clearly accepts it 2, 4, 6 times. And it'll allow any not A's on the right and any not A's on the left and any not A's in between, which is what this one does as well and what this one does as well. All right, the next one, it's the same thing, except the not A star, instead of being factored out of the rear, has been factored out the front. We've taken this one out and factored it out. So we got any number of not A's on the left, followed by an A with any not A's between them, followed by an A with any number of A's after it. So it can both start with and end with an A. So if this thing took 0 not A's and this thing took 0 not A's, we can start with and end with not A's. We could also start with A, because this thing right here could take 0 not A's. That would allow for the A. And this thing right here could take 0 not A's at the end, which would allow the A to be at the end. So these are still the same. This one factored the not A out the back, and this one factored it out the front. But that's allowed because when it repeats, in the middle, it will always put these two not A's side by side. And one of those is the same as two of them, because they'll both match the empty string. Okay. The next one, I'm going to come back to this when we're done, because now I'm concerned I've made a mistake. All right, so what did we do? Here we factored it out the back. Here we factored it out the front. All right, here it factored it out both sides. All right, and the question is, are these the same? I'll give you a minute to think about it. So recall, this one is an even number of A's. And then is this the same thing, the one right here? All right, so the thing that allowed us to factor, where is it? This expression here is that when it repeats, it's going to put the not A stars beside each other. All right, so if we have this sub-expression, and it's going to be appearing, oops, go away. So it could occur 0 times because the whole thing was clean star. It could occur once, and again, I missed that star when I copied it. And we get this. It could occur twice. It could occur 3 times. All right, so let's just look at the twice case. Every time it repeats, it has this little group right here, right, where it says not A star, not A star. So if we have something star, the same thing star, then that's the same as just having it once. Okay, so all that junk there, let's ignore, and let's just look at, let's do dashes, or we'll do hats. We're going to look at this junk here. That sub-expression is the same sub-expression as this guy. Oops, with lowercase. That guy. Right, because if we have 0 or more not A's followed by 0 or more not A's, if I add those two statements together, all it's really saying is 0 or more not A's. So it's the same as this one. So that's what allowed me to factor out one of these not A's. Now the problem is this factorization took out the one at the front and the one at the back, which is not okay. All right, so if you take this expression here, let's just look at it. Oh, that's not what I wanted. Copy. Okay. So I'm going to change it. So this little grouping in the middle, ignore the spaces. They're not part of the pattern. But if I was to do this, we're off by 1. There we go. So these two are the same, right? Because this sub-expression in the middle is the same as this. So that means I can replace this with this, and we have the same pattern. The problem is the next guy took it one step too far. So let's put him down here. All right, and we're not looking at the starts with. Those hats and dollar signs are there. I just don't want to put them in every time. So the problem that the next thing tried to do is it factored it out both sides. So really, we've taken this guy. Well, I'll just do it. So it says, starts with a bunch of not A's, and then we have this thing in the middle, which I'll copy because I'm going to repeat it. Like that. If it occurs twice, I get this. Right, so literally all I did was take the sub-expression in the middle and repeated it 2 times. So again, these are my outer guys on the outside, and I'll just put the brackets for where the clean starred thing is. That's this part right there. So we've got not A star on the right and not A star on the left, and then we have this thing in the middle repeated 0 or more times. Okay, so here it is 0 times. Here it is 1 time. There it is 2 times. So I'm just going to separate these to show where they match. So they match on the left and the right, but they don't match in the middle. So this one will allow any characters that are not an A to appear between the two groupings. This one will not. Doesn't allow anything to be there. Okay, so the counterexample for this would be ABA. So these two would both accept ABA, well, when they occur singularly. Actually, no, that's not good enough. ABA, B. Okay, let's do this. AAB, AA. That's the counterexample, because I need it to occur between the repeats. Okay, so let's look at it, make sure that I'm right. All right, so here's our input string. Let's give it to this one first. Okay, so we've got an A, but we said we can have 0 or more not A's. So right before that first A, there are 0 things. So that's fine. We're okay up to there. Then this A matches that A. And then we've got 0 not A's right there. That's fine because there's 0 things there. Then that matches that. The A matches there. And then the B will be taken by the not A star. And then this A matches that A, and then there are 0 not A's right there. This A matches that A, and then there are 0 not A's right there. So this is accepted. So that input string was accepted by this pattern here. Okay, now we're going to try the same input string for this one. All right, so we got not A star, no problem. There are 0 not A's in front of it. Then there's an A, and then not A star, no problem. There are 0 not A's right there. So that A matches that. And then we need to match the thing that's on the right. So I'll try to push it over. You can't really do that. But here, what happens is there has to be an A there, but instead we've got a B. So this is rejected. So this one up here says an even number of A's, but this one down here is a much more complicated language. You're allowed to have an A out on the left and an A out on the right, but then any A's in the middle have to be side by side. They have to be in a row. So the language would be you have an A on the left and an A on the right, with anything actually on the left or right of that, or sorry, any not A's on the left or right of that. But any A's in the middle have to be side by side. So I would never ask you to describe that language because it's complicated to describe it in words, but the gist of it is these two A's in the middle cannot have anything in between them. Whereas these two A's here, they do allow for not A's in between them. So this string AABAA is accepted by this language, but it is rejected by this language. So on an exam, I asked you, are they the same or different? If they're the same, describe the language. If they're different, give a counterexample. What I'd want to see is AABAA accepted by first, rejected by last. That's it. So here's your counterexample. You tell me which one accepts it and which one rejects it. So the fact that this substring, or this input string, is accepted by one of them but not the other one means they're not the same language. They're different. All right, now let's go back up here. What am I trying to say with that B? Just a B is rejected by both of them, because it says starts with, ends with. ABA would be accepted. ABA would be accepted. BAA would be accepted. BAA would be accepted. Yeah, no, I think these are the same. If I go inside here, I commit to having two A's. But if I'm in here, I'm committed to having two A's anyway. Oh, wait, these two are not the same. What am I talking about? Because that's exactly two A's, whereas this is an even number of A's. So these two are the same. Yeah, you're correct. Sorry, I was overthinking it. This one has to have two A's, but this one does not. It's an even number of A's. So 0 or 2 or 4 or 6 or 8, etc. Okay. Okay, now are these two the same? Yes, they are, because that contributed nothing. Ooh, no, they're not. These two are not the same. That's what it's talking about. This guy will accept the B, just a B. This one will not accept just a B. Because if I go inside the round brackets to say, okay, my B can be matched by that, then I'm also committed to having two A's. Right, but here, if I give it just a B, then this clean star says, okay, I'll take nothing, and then this thing will take the B. So these two are different. Madness. That was super tricky. That one needs to be marked as really hard. Look at that, it even had the answer and I didn't see it. Very complicated. Okay. All right. Well, everybody makes mistakes. I make them all the time. All right, let's look at these guys. An A followed by a non-word character, and an A followed by a word boundary. So first question is, are they the same? And if not, give me a counterexample. So I'm going to let you think about that one for a moment. Are those two the same? And if not, give me a counterexample, and if they are, describe the language. Sorry. If you claim they're different, you have to give me a single counterexample. You can't give two things. And let's look at it. We got an A followed by a non-word character, and an A followed by word boundary. So I'm going to look at the two you gave me, A hyphen A. Okay, well, A hyphen clearly matches this one, because we've got an A followed by a hyphen. Okay, so that's accepted. Is it accepted by this one? A hyphen A? Well, the first A has a word boundary after it, so that one also accepts your first example, which is A hyphen A. So that's not a counterexample. It's accepted by both of them. The next one you've got is AA. Okay, well, AA will be accepted by this one. The first A is ignored, and it says this is the second A, and that's at end of line, and end of line is a word boundary. So the second one accepts AA. The first one, however, does not accept AA, because if it takes the A to be the second one, it must be followed by a word character, but it's not. It's end of line. And it also can't be the first A, because the first A is followed by the second A, which is a word character, so it's not a word character. So AA is an acceptable counterexample, because this one will accept AA, but this one will reject it. And in fact, just the single letter A would be a sufficient counterexample, because this one accepts a single letter A, whereas this one does not, because it needs an A and then a non-word character. So those two are different, because this guy down here accepts just an A, this one does not. All right, so let's look at this crazy thing. We've got an A, a word boundary, and then maybe there's a space, maybe there's not. And the question is it the same as the one that comes before it? And if it's not, give a counterexample. I'll give you 30 seconds to think about it. All right, so this one says an A followed by a word boundary. So far we're exactly the same as the one above. And then it says 0 or 1 spaces. Well, if there can be 0 of them, then it's identical to the one above it. Right, so what if there is a space? No problem. This guy will also accept A followed by a space, because that would create a word boundary. So these two are the same. It's describing the language that contains an A at the end of a word. And this one is also describing the language, contains an A at the end of the word. Because this guy is out on the right on his own with a question mark, it means there could be 0 or 1 of them. And if there can be 0 of them, well, then it's identical to the one above. Now, there's nothing else following it, so we can just say that. Good. Okay, the next one says A, add a word boundary, and then a non-word character or not. So 0 or 1 non-word characters. So I'll give you 30 seconds to think, is that one the same as the two that came before it? Okay, so what do we got? An A at a word boundary, followed by maybe a word or non-word character. Okay, well, space is a non-word character. So if it's a space, then the two of them are the same. What happens if it is a not space, like a hyphen or something? So what if I gave it just a hyphen? Well, a hyphen is going to be accepted by this one, because it's an A and then a non-word character, so that will have a word boundary after the A. A hyphen is also accepted by this one, because we've got an A and then a hyphen, so that means between the A and the hyphen there was a word boundary. And then I'll just say there were 0 spaces, so the question mark will take 0 spaces. So this one will also match A hyphen. And then this one down here will definitely match A hyphen, because it says there's an A and a word boundary. So if I decide that this capital W is the hyphen, then it accepts that as well. Okay, but you can't prove that two things are the same by giving an example, because I could say maybe there's some counterexample you haven't thought of. Right, so really it's describing the language. It's still A at the end of a word, because it's A at the end of a word, maybe or maybe not, followed by a non-word character. Because of the fact that we said or maybe not means that they're the same, because if we say not, then it's exactly the same as this expression here. So again, because the question mark allows 0, then it can reduce to this, because there's nothing else on the right. If there are other things on the right, that would change things. But because there's not, this is the rightmost, and because it's a question mark, there could be 0 things, so it's not contributing anything to this expression. So far we're still just A at the end of a word. All right, next one. This one's a little trickier. We got an A, and then maybe or maybe not a non-word character, but then definitely a word boundary. So remember, the definition of a word boundary is a transition from a word character to non-word character, and end of line is considered to be a non-word character. All right. So there's definitely a word boundary between our A and this /W, if the /W exists. If it doesn't exist, if the question mark takes no things, then again we're reduced down to just A/B, which is identical to this one. So there's two cases to consider. What if the question mark takes no things, and what if the question mark takes one thing? All right, well, if it takes no things, then it is completely identical to this one right there. Right, because that says this will occur 0 times, then we're just left with the A/B, which is completely identical to this. So if this occurs 0 times, they're the same. What happens if it occurs 1 time? All right. It looks like there might be a problem, because I can come up with this. Where is he? If I talk about this one, A minus minus, right, there's my A, there's my non-word character, but right there where the cursor is blinking is not a word boundary. Whereas my pattern says there must be a word boundary there. Okay, so if I do this, so if it was A, W, question mark, /B, this is my input string. So I could try to match it with the A there, the hyphen there to match the W, or yeah, the capital W. Then I've got a problem, because in between the two hyphens is not a word boundary, so I cannot match the /B there. So it looks like it might reject it, but it actually doesn't. So my potential string for breaking it, it can go along and say, okay, I'll look at your string. The A matches that A, no problem. But then right there are 0 non-word characters in between the A and the hyphen. So here it's made the W question mark be 0 or empty again. And then we're at a word boundary because we're transitioning from an A to a hyphen, so from a word character to a non-word character. So my attempt to break it just left me with the same thing. So that means these two languages are the same. And we're still at an A at an end of a word. All right, the next one, A/S question mark /B, we can use the exact same argument as the one up here. If I give it a space then a hyphen, it will just actually say, well, that space, the question mark will not take it. But then because we went from an A to a space, that's a word boundary. So that will be fine. Okay, what about A hyphen hyphen? No problem. We'll just say there was no space there. And since we're going from an A to a hyphen, then there's a word boundary. So that's accepted. All right, so we can go through all these arguments, but we cannot find a counterexample. So that means they're the same. It's an A at the end of a word. And again, because this could be 0 things, it allows me to collapse the entire expression down to just A/B, which is exactly what I started with, A/B. Okay, next one. Oh my gosh. A/B, and then maybe, maybe not a word character. /B, maybe, maybe not a word character. All right, I have a pretty strong suspicion, but I want to think it through. Sorry, let's move that guy out of the way. Pretty sure this one is the same. By the same argument we've made above, if the /W is not there, then the two /Bs come together. Like if we say this is matched with 0 things, then these two guys collapse together. And then /B/B is just the same as /B because it's a position, not a character. And then, so I'm left with A/B/W question mark. Well, I've already convinced myself that that's the same up there. Trying to break it, and I can't. So if I give it A hyphen hyphen again, it's just going to say, no problem, the A matches the A, and then from between the A and the hyphen, there is a word boundary. But then it's going to say, okay, I just refuse to take that hyphen. We're still between the A and the first hyphen, so that is a word boundary. And then I refuse to take your second hyphen, or the hyphen again. So just the A will match in that sub-expression. So if I give it A hyphen hyphen, it will still match this pattern because it will just not take the hyphens in the question marks. And I'm allowed to do that because I can say those two hyphens are just on the right, outside of the expression. So I'll actually do this one to completely convince you, and then I'll trace it. Because I know that that seems really wrong. Okay, so we're going to do a grep, and it's going to be an extended regular expression because I got question marks going on. And we'll insert that guy right... Oh, no! Oh, no. Okay, I'll just have to type it. No, I don't want that. Do grep-e, and what have we got? We've got A /B /W question mark, /B /W question mark. Is that it? Yeah, that's it. All right, so if I give it A hyphen hyphen, it's accepted. What's the lab assignment? D2L. The assignment's already, the lab is already posted. I haven't got the assignment up yet. All right, let x be any expression. If it's x question mark or x star, do they always collapse if it's chained? Like this. Okay. I'll come back to the longer question. Let's just do the what about just A, okay? Just A. accepted. So it takes the A right there, and then it says 0 not word characters, 0 not word characters, but there has to be /b/b, but end of line is a word boundary with a word character. So that's still an A at the end of a word. And I hope if you're looking at it, you are convinced that that's A at the end of a word, because it is just the letter A. So that is at the end of the word. Okay, next question. The previous question is it X question mark or X star? Do they always collapse if it's chained, like this or this or this or this? All right, so I'm going to copy your examples, and then we'll work through them. So here's your examples. So the question is, do they always collapse? All right, so don't worry too much about the math. Just look at what this is saying. This says 0 or 1 x, 0 or 1 x. All right, so think about what the minimum and the maximum could be. So we have 0, 1, or 2 x's. Those are all permitted. So you're asking, could it collapse to this? If there's nothing else on the left and the right, yes. But if there are things on both the left and the right, no. Because this is exactly 0 or 1, whereas this was 0, 1, or 2. Now, the reason I say if there's nothing on the left and the right, yes, it's because you didn't say starts with, ends with, so you can sneak more x's in on the left or the right, no problem. But if there's things on both the left and the right, you cannot sneak x's into the middle, so you can't handle that extra x. Okay, now this one, x star, that one definitely collapses to x star in all cases, because what does it say? It says 0 or more, 0 or more. If you add those two together, you still get 0 or more. Now what about this one? It says 0 or 1, followed by 0 or more. So this is like, what happens if you add 0 to infinity? You still have infinity. What happens if you add 1 to infinity? You still have infinity. So the minimum number we can have is 0, and the maximum number we can have is infinity. So that is the same as that. And the exact same argument applies to the other case here. So these are all true in all cases. But this one here, it depends on if there's stuff on both the left and the right, because this one there will accept 0x's, 1x, or 2x. Whereas if you tried to collapse it to this, that's just 0 or 1. So imagine we had the expression x question mark, exactly as it is. Then those two by themselves are the same as x question mark. Because if there are 0, 1, or 2 of them, well, then there are definitely 0 or 1 of them. Okay, but if you have something like a, x question mark, b, right, then you've got a problem. That is not the same as a, x question mark, b. Because in here, there's an a, and then there's either 0, 1, or 2 x's, and then a b. Whereas over here, you've got an a, and then either 0 or 1x, and then a b. So the counterexample would be axx, b. So if I was to say, as my input string, axx, b, all right, so axx, b will be accepted by this one. Because it'll say, okay, I've got your a, I've got 1x right there, I've got the second x right there, and then I've got your b. So axx, b is accepted by the first one. axxb is rejected by the second one. Because it says, I've got your a, I've got your x, but then it has to be followed by a b. Whereas down here, it's not followed by a b, it's actually followed by an x. So the first one would accept axxb, but the second one would reject axxb. So in that case, they're not the same, but it's because I restricted what can be on the left and the right. Right now, but if they're just by themselves, then I can sneak as many x's as I want on the left and the right-hand sides. So if I give this one axxb, well, it ignores the a, and it starts matching that sub-expression right there. So I've got a substring that matches the pattern, because the xx will match those guys, it's accepted. Okay, and in fact, this will match the empty string. Right, and likewise, this will match the empty string. So if all we're looking for is the empty string, every input string contains the empty string. So that will accept AXXB, both of them, because they both contain the empty string. But here, when I put the A's and the B's around them, it won't accept the empty string anymore. Right, there has to be an A and a B, and then this guy says 0, 1, or 2 x's between them, and this one says 0 or 1, but not 2 x's between them. Does that answer your question? I'm going to assume yes. If you're typing more, I'll answer it. All right, so what did we have here? We had A, \B, W, question mark, and I just went through the whole rigmarole to convince myself it's the same as this one. All right, what about this guy? A \B, W, question mark, capital B, W, question mark. Okay, something different going on there for sure. So whatever. Let's take a look at this. There we go. Like this. Okay, what have we got? And we're comparing it to our old friend A \B. All right. Okay, so the problem here is when I was looking at, no, I'll just type it out, it'll be faster. When I was looking at this guy, this one of the things I did is I said, well, this could be 0 things, which just collapses down to that, which just collapses down to that, which was one of our previous examples. Right, so I know it's the same as this one. But I can't do that to this new string. Because if I come along and I say, okay, well, we'll just say that this happens 0 times, I got a problem, because this location cannot both be a word boundary and not a word boundary. So I can't do that. So actually, this W question mark business, it's not going to fly. This guy on the end, he doesn't contribute anything. Because he's on the end, he can occur 0 times, so I can just ignore him. Right, but now I'm left with this. The only way that I could have a word boundary here and then not a word boundary after it is if there is a non-word character here. So you can't have 0 of them, basically, because that's impossible. Okay, so there has to be at least one of them. So let's get rid of the question mark. And then the only way for this to not be a word boundary is if it's either end of line or another word or non-word character. All right, so I strongly suspect that they are not the same. So let's come up with a counterexample. Okie doke. A hyphen. Just A hyphen. What do we got? We got an A. Well, let's do, oops, sorry. Let's do A hyphen right here. Yeah, so the /B will match the position between the 2 hyphens because that is not a word boundary. If you're more comfortable doing A hyphen hyphen, we'll do that. All right, so we got an A, and between the A and the hyphen is definitely a word boundary. No problem. All right, and then I've got a W question mark, so there could be 0 or 1 of them. I know that there can't be 0 of them because you can't have a word boundary also be a non-word boundary. So this hyphen has to be there. Okay, then there has to be a non-word boundary, but this is end of line. So that is not a non-word boundary. Or actually, is it? Not sure, but that's more difficult than I want you to think. Let's try this guy, A hyphen A. A hyphen, well, that's a word boundary. That matches this capital W. And then I've got another A there, but that is not a non-word boundary. So that's not possible. Okay, so this one will reject A hyphen A. Okay, is there any way I can make it accept it? So we got an A, And then there has to be a word boundary, so there does have to be a non-word character there, which matches to that. And then this says there has to be a non-word boundary, so if I throw a word character there, it will break it. So that's a reject. Okay. Now a\b, that one will accept a hyphen a, actually in two different ways. So if I have a hyphen, that's an a followed by a word boundary right there. And this one is also an a followed by a word boundary because it's end of line. So it looks like a hyphen a is my counterexample. I'm totally convinced of this one being accepted. Let's make sure that this one is rejected. Okay. So we'll do a grep, extended regular expression, insert that guy, and then we'll give it a hyphen a, and it's rejected. Good. Whereas a\b will definitely accept that. So we'll try out a\b, like that, a hyphen a, accepted. All right, so there's my counterexample. A hyphen a is accepted by a\b, but it's rejected by that madness there. So because I found a counterexample, that proves that they're not the same. Okay. That was a tricky one. All right, we've only got like, what is it, 3 minutes left, I think? I can't see the time because my stupid thing is in front of it. Maybe if I clear the history. No, what if I switch to private? There we go. Oh, we're done. All right, so we can also have repeating characters. I'll leave you to read this. There's tons of examples in the slides, so there should be no surprises. The way it works is you say curly bracket. If you give a single number, it means exactly that many. But remember, even if I said exactly 4 A's, then a string with 5 A's would contain 4 A's, so it would still be matched, unless I restricted the left and the right-hand side somehow. All right, this one is for a range, so the minimum and the maximum. But again, with the same thing, maximum gets an asterisk because unless you restrict what appears on the left and the right, more of them can sneak in. So I'll scroll back to the slides. This guy is the minimum. This says whatever that number is or more. And this is a maximum. So it says up to this many. Or that we could do it like this. There's at least 0, and then there's up to m. Okay, so let's look at these guys. Does this demonstrate what I wanted it to demonstrate? That all has restrictions on the left and the right. I want to make sure there's an example that doesn't have a restriction. Yeah, so this one doesn't, but I don't think it matters. All right, so I'll give you one quick example to show what I'm trying to demonstrate. If I just said a, let's do 4. A curly brackets 4. That says 4 A's in a row. So it contains 4 A's in a row. So if I give it the string AAA, that's rejected because there's not enough A's. If I give it AAAA, that is definitely accepted because there's your 4 A's. All right, but if I was to give it 1, 2, 3, 4, 5 A's, that is also accepted because, well, right there, that's 4 A's, and that was enough to satisfy this thing. Now let's throw a B on the end of it. Okay, our first one's still rejected, not enough A's. Okay, what if it was 4 A's followed by a B? Yeah, that's accepted. It is literally 4 A's followed by a B. What about 5 A's followed by a B? That one's still accepted because right there is 4 A's followed by a B. So it's going to match this substring. So even though there was 5 of them, it's accepted. All right, so what if I throw a C on the front of it? Okay, so we got to throw a C on the front of both of these guys. We got a C, and then 1, 2, 3, 4 A's, and then a B. So this is literally what that says, so it's accepted. Now this one will get rejected. So what'll happen is, it'll look at this and it'll say, okay, there's your C. Actually, I'll pull it up. There's your C right there. Okay, and then you've got 1, 2, 3, 4 A's. We're doing good. So it matches up to this point. But the problem is it says, then there's a 5th A. whereas my pattern says there must be a B. So this one would get rejected because this one says a C with exactly 4 A's and then a B. So it'll be fine. There's your C, there's your 1, 2, 3, 4 A's, but then this A right there is not the B. So it gets rejected. So this one restricted both the left and the right, so it was not possible for me to sneak in more A's. Now, if I don't have anything on the right, I can sneak more A's in on the right, and then it's fine. If I don't have anything on the left, I can sneak more A's in on the left, and it's fine. So this string would be accepted by this thing up here, because it'll look at it and say, oh yeah, that C, I'm just going to ignore it because you didn't say starts with. This A, I'm also going to ignore because I'm a non-deterministic finite automaton. I always make the right decision. So I'm just going to ignore it because you didn't say starts with. And then it'll say, okay, here's your 4 A's and your B. So that's accepted. Okay, so I hope that example was sufficient. Please review those slides. And actually, the lab quiz makes use of that. So there is something that uses the curly brackets on the lab quiz. Okay. Does anybody have any questions about this material? Okay, so I guess I forgot to put the lab quiz in the content, but it is up on D2L already. Yes, I did. So existing activities, quizzes. That one. Yes. Okay. Automatic. Okay, so I'll see you guys for lecture tomorrow, or at least I'll see the little number that indicates that you're watching me tomorrow. I'm going to do the same lecture material again for the other lab section if you would like to see it, but this stream is going to end and I'll start a new one.